Hello, today you will learn about the amplitude modulations calculations. Now we go to example 1. For a conventional AM modulator with a carrier frequency of Fc equals to 100 kHz and the maximum modulating signal's frequency of Fm maximum equals to 5 kHz, determine A. The frequency limits for the upper and the lower sideband. B. Bandwidth. C. The upper and the lower side frequency produced when the modulating signal is a single frequency of 3 kHz stun. And D. Draw the output of the frequency spectrum. Let's go to the solutions. First, we must guess all the information from the example. Okay, we found out that the carrier frequency Fc is equals to 100 kHz and the maximum modulating signal is the frequency Fm maximum equals to 5 kHz. Then A, we want to find the upper and the lower sideband frequency. So upper sideband is equals to Fc plus with your Fm maximum equal to 100 kHz plus with your 5 Fm maximum kHz, you will get 105 kHz. For the frequency lower sideband is Fc minus Fm max equals to 100 kHz minus of 5 kHz equals to 95 kHz. Then we go to B, bandwidth. To find the bandwidth, we can use the formula bandwidth equals to upper sideband frequency minus of lower sideband frequency, which is 105 kHz minus of 95 kHz equals to 10 kHz. And we can use another method of bandwidth equals to 2 times of our Fm maximum, which is 2 multiplied with 5 kHz equals to 10 kHz also. Okay, then we go to question C. Okay, for this question C, we have to find the upper and the lower sideband when the modulating signal is equals to Fm maximum is 3 kHz. And from the questions previously, we have Fc is 100 kHz. So to find the upper sideband, we can equal to Fc plus with the Fm max is equal to 100 kHz plus with 3 kHz, and we have 103 kHz. And this 3 kHz is the new value for the modulating signal. Okay, for the frequency lower sideband will be equal to Fc minus of Fm maximum, which is 100 kHz minus of 3 kHz, we will get 97 kHz. For the bandwidth, we can find through frequency upper sideband minus of frequency lower sideband, which is 103 kHz minus of 97 kHz, we get 6 kHz. Or we can use another method equals to 2 multiplied with our Fm maximum, which is 2 times 3 kHz, we will get 6 kHz. Okay, then now we want to draw out our output of the frequency spectrum. First, we have to write out our x-axis. Okay, so our x-axis is in megahertz. We have 95, 97, 100, 103, and 105 megahertz from the previous calculations. And then we know that our Fc is equals to 100 megahertz, so we draw out our Fc. Then we will, from the question A, the bandwidth equals to 100 megahertz. Okay, we calculate our Fc minus Fm is 95, and our Fc plus Fm is 105. Then for question C, we have our Fc plus Fm is 103, and for the Fc minus Fm is 97 megahertz. And we draw out for the answer for the C, the frequency, upper sideband and lower sideband. That's all for example 1. Okay, now we go to example 2. One input of a conventional AM modulator is 500 kHz carrier with an amplitude of 20 dB. The second input is a 10 kHz modulating signal that is sufficient amplitude to cause a changes in the output wave of plus minus 7.5 dB. Okay, so we know that we have a modulator, and this modulator we will have an input of Fc and another input is Fm, modulating signal. Okay, then after we undergo the modulation process, and we will provide an output is the amplitude modulation signal. Okay, so this is the process. And these two add up, you will have this output lah. Okay, so question A, determine the upper and the lower sideband frequency. Okay, so from here, we know that our output will be in double sideband because it's a conventional AM modulator. So we know that our output is a double sideband full carrier. So we will have a modulating signals and our carrier. And this signal may generated. Okay. So B is a modulations index and the percentage of modulations. C, find the peak amplitude for the modulated carrier and the upper and lower sideband frequency voltage. D is the maximum and the minimum amplitudes for the envelopes. And E, express the modulated wave. Okay. Now we go to A. Okay, before we go to A, we have to take out all the information from the questions. So we know that it's a conventional AM modulator and our carrier frequency FC is 500 kilohertz and our maximum modulation signal is FM maximum equals to 10 kilohertz. Then from the question, we have the here, okay, we have two value, 1 and 2. And this first value is the amplitude, which means is the voltage for the carrier, 20 Vp, and we also have the voltage for the our modulating signal is plus minus 7.5 Vp. Okay, so this is the information we get. So EC is equal to 20 Vp and EM is equal to plus minus 7.5 Vp. Okay, now we go to our question. A, find the upper and the lower side frequency. So we have the formula F frequency for upper sideband equals to FC plus FM maximum 500 kilohertz plus 10 kilohertz is 510 kilohertz. For the lower sideband frequency is FC minus of FM equals to 50 kilohertz minus of 10 kilohertz equals to 490 kilohertz. Then we go to B, find the modulations index and the percentage of the modulation. First, modulations index is M. The formula is equals to EM divided by EC. So we have the value of EM is 7.5 divided by our EC is 20. Just substitute inside, we will get 0.375. Okay, to find the percentage of modulation, we just have to multiply our M with the percentage. So EM divided by EC multiplied with 100 percentage, and we will get 33.5%. Okay, that's easy. Then we go to C. Before we go to C, we have to calculate D first in order to get C. So for the D, for this question, the D is the maximum and the minimum amplitude of the envelope. We have to find the maximum and the minimum amplitude of the envelope. We only can find the peak amplitude for the carrier. Okay, let's go. Okay, D, maximum and minimum amplitude for the envelopes. How you want to find that? So you still remember the maximum envelope is V maximum equals to EC plus E USB plus E LSB. Okay, so we have the value of EC, we know it's 20, but we don't have the value for EUSB and ELSB. Okay, now you want to find EUSB and ELSB. Okay, recall back. We have our modulations formula, modulations index formula EM divided by EC, and we rearrange it, we will have MEC equal to EM. Okay, this one is our equation number 1. Okay, then we know that our EUSB is plus with ELSB is equals to EM. So these two are the same value, they are equal. So we can assume that LSB is equal to USB. So we will have EM equals to 2E, our voltage, okay, upper sideband. Okay, so it's 2 times. So to find our EUSB is equal to our EM, our voltage for the modulating signal divided by 2. This is equation number 2. Okay, now we have to substitute equation 1 into 2. So start with 2. EUSB equals to EM divided by 2. Okay, now EM we need to substitute with MEC. Okay, put inside, we will have our voltage for our upper sideband equals to our voltage for our lower sideband. It will be equal to our modulations index multiplied with our voltage for the carrier signal divided by 2. Okay, so we get this formula. And we using this formula to substitute in these two values. Okay, first, we substitute inside. Okay, then EC is 20. M is just now we calculate 0.375 multiply EC 20 divided by 2 and M is 0.375 multiply 20 divided by 2 and we put in calculator we get the answer 27.5 volt for our positive V maximum. Now we want to find our positive minimum amplitude for the envelopes. So positive V minimum is equal to EC minus of EUSB minus of ELSB. So we just substitute our EUSB and ELSB with MEC divided by 2. Okay. And then we just put in 20 minus of 0.375 multiplied with 20 divided by 2 and minus of 0.375 multiplied 20 divided by 2. And we get the answer is 12.5 volts. Okay. Then now we go back to C. C is to find the peak amplitude of the modulated carrier. This is the formula is EC modulated is equal to 1 over 2 V maximum plus with V minimum. That's why I said that we must find the V maximum and V minimum first before we can find the EC modulated. Okay, that's why we do question D first. Okay, now come to C. Okay, so just now, the previous we already counted. We know that our V maximum is 27.5 volts and V minimum is 12.5 volts. So we just substitute into these equations and we'll get 1 over 2 multiplied with 27.5 plus with 12.5 volts and we get 20 volts. Okay. Then the upper and the lower side frequency voltage. So we can calculate from here. EUSB plus V of ELSB is equal to 1 over 2 V maximum minus of V minimum. So we will have 1 over 2 multiplied with 27.5 minus of 12.5. Okay, we get 15 and 15 divided by 2, we will have 7.5 volts for our EUSB plus with ELSB. And you still remember EUSB plus with ELSB actually is our EM. Okay, for our modulating signal. So it's equal to 7.5 volts. Okay, this is proven as in the question that is. Then we go to E, expression of the modulated wave. Now we want to express out our AM modulated wave signal. So we just draw it. Okay, so we will have our upper sideband frequency signal and our lower sideband frequency signal, and in the middle is our carrier signal. Okay, after we draw it out, okay, then we know that our V maximum is equal to EC plus EM. So we calculate just now is V maximum equals to 27.5 volts, and then we know our V minimum is EC minus EM is 12.5. We have calculated, and for the negative side is the same, just change in negative value. Okay, and negative V minimum is negative 12.5 volts. Then we have calculated our EC and our EM. EM is 7.5 volts and EC is 20 volts. Just label in the modulated wave. That's all. So easy. Thanks. Then now we go to our AM power. Now we recall back our AM power distribution formula. So we have the power unmodulated carrier PC is equal to VC divided by SERT2 bracket square divided by R, and we will have our VC square divided by 2R. And this is the power for the unmodulated carrier formula. Then we recall back, we have our upper and lower sideband power is this formula. P USB equals to P LSB equals to M VC divided by 2 bracket square divided by 2R, and it's also equal to M square VC square divided by 8R. Okay. And rearrange it in the PC term, okay, the power for the carrier term. So we know that this part is our carrier. Okay, so we will have M square divided by 4, and our carrier is VC square divided by 2R, and this part we substitute with PC, and we will have M square divided by 4 multiplied with PC. And then we recall back. Our total power of the AM wave is P total equals to PC plus with P upper sideband plus with P lower sideband. Okay, and we also can do this total power in the term of PC, and we have this formula. P total equals to PC plus with M squared divided by 2 PC, or also equal to PC multiplied with 1 plus M squared divided by 2. Okay, and we also recall back our power spectrum for our AM double sideband full carrier wave is look like this, and this is our x-axis is in frequency, our y-axis is in power watt, and we can label the value for our FC, F upper sideband, and F frequency for lower sideband, as well as the power itself. Okay, and then we also have the output power formula can be calculated by P total equals to I total square multiplied with R, and this I total is measured in RF current, and this RF current and the R is the antenna impedance, and the I total is expressed as this one. The IC is the unmodulated carrier currents, and multiplied with the root square of 1 plus M square divided by 2, and this formula. Okay, now we go to the transmitter efficiency formula. Transmitter efficient formula is equal to M square divided by 1 brackets 2 plus M square multiplied with 100. And this is the formula. Okay. Now we go to example 1. Give a unmodulated carrier current of an AM transmitter is 10 ampere. Antenna load impedance is 50 ohm, and the percentage of modulation is 85%. What is the total AM transmitter power? Okay, from here we have the solutions. We have to find out the current first before we calculate the total ampere AM transmitted power. So the current is I total equals to IC square root 1 plus M square divided by 2. Okay, so IC is 10. So we have 10. This one is the current for the carrier. So IC. Okay, then we have the loads. Okay, is 50, R is 50, and a percentage is 85. So this percentage of modulation is our modulation equals to 0.85 modulation index. So we substitute inside the M. Then we will get the value 11.67 ampere. Then only we calculate our P total, the power transmitted total, equal to our I total square R. So our I total is 11.67 square multiplied with 50, we will get 6,809 volt. Done for example 1. Now we go to example 2. Example 2. For the AM double side carrier, full carrier wave with a peak of unmodulated carrier, voltage is VC equals to 10 VP, and the root resistor RL is 10 ohm, and the M is 1. Okay, here is clearly list down. We have 3 parameters, 1, 2, and 3. Okay. Then determine the power of the carrier and the upper and lower sideband. B, find the total sideband power. C, find the total power for the modulated wave. And D, draw the power spectrum. And this ABCD, we can use the formula just now I told you. Okay, then we repeat the step A to D when the modulating index is equal 0.5. Okay, now we go to the solutions. First, we list down the first one. VC is equals to 10 VP, information from the question. Second information is the load resistor of RL is equals to 10 ohm. Third information is our modulating index is equals to 1. Then we start with the A, power of the carrier and the upper and lower sideband. Okay, so power for the carrier PC equals to VC square divided by 2R. Just substitute inside 10 square divided by 2 multiplied with our 10 ohm. Okay, this 10 ohm, and from this 10 is the square, and we'll get 5 watt. Then we find for our upper and lower sideband. Upper is equal to lower sideband is equal to M square divided by 4 PC. So our M is 1, so square divided by 4 multiplied with our PC 5, and we will get 1.25 volt. Okay, now we go to B, the total sideband power. So P total sideband TSB equals to PUSB plus with PLSB. Okay, upper sideband and lower sideband power. Okay, will be equal to 1.25 volt plus with 1.25 volt, we will get 2.5 volt total sideband power. For C, we find the total power for the modulated wave. So for the power total is equal to carrier power plus with upper sideband power plus with the lower sideband power. Okay, so we will have P total equals to 5 volt plus with 1.25 volt plus another 1.25 volt equals to 7.5 volt. That's easy. Then we go to draw the power spectrum. Okay, this is very easy. You just have to draw out your x-axis is your frequency and your y-axis is your power. Okay, then you draw it and label it. Your PC is equal to 5 volt. Your PLSB is equal to 1.25 volt. And your PUSB is 1.25 volts. That's all. Then we repeat the step A, B, C, D for the modulating index when equals to 0.5. It's easy. We want to calculate the first one, the A, repeat the A, the power of the carrier and the upper and the lower sideband. We just use back PC equals to VC squared divided by 2R. Then we substitute VC is 10 voltage, and then our R is 10 ohm. We will get 5 volts for PC. Then the PUSB and PRSB, here's the difference. We have to substitute our M with 0.5, then square and divide by 4 multiplied with 5. And we'll get 0.3125 volts. And then we calculate for our total sideband power. Same. We sum up PUSB and PRSB. So we'll get 0.625 volt. Then we find our total of our modulating wave. P total equals to PC plus PUSB plus PRSB. Okay, 5 plus 0.3125 plus with 0.3125, we get 5.625 volt. Okay, then we draw the power spectrum. Da-da, and we do the label. Okay, that's all. Okay, now we go to, this is the answer for the, summary answer for the example 2. Okay, now we go to the modulating index for a complex information signal. Here is the formula. M total is square root of M1 square plus M2 square plus M3 square until the Mn square. Okay, so we go for example 3. For an AM double sideband full carrier transmitter with an unmodulated carrier power PC equals to 100 volt. That is modulated simultaneously by 3 modulating signals with a coefficient of modulations M1 equals to 0.2, M2 equals to 0.4, and M3 equals to 0.3. Determine A, the coefficients of the modulations. B, upper and lower sideband power. C is the total transmitted power. Okay, so first we list down the unmodulated carrier power. PC is 100, and M1 is 0.2, M2 is 0.4, M3 is 0.3. Okay, A, we find the total coefficient for modulations. We just use the formula. Mt equals to square root of M1 square plus M2 square plus M3 square, and we will have 1.2 square plus 0.4 square plus 0.3 square, and square root of, we will get 0.5385. This one is our modulation index. For B, we want to find the upper and the lower sideband power. We just use the formula. Okay, equals to M squared divided by 4 multiplied with our PC. We substitute our M is 0.5385 squared divided by 4 and multiply with 100 our power for carrier. We will have 7.25 volts. And the total transmitter power, we just sum up PC, upper sideband and lower sideband power, and we will have 100 sum with 7.25 and plus with 7.25, we will get 114.5. That's all. Thank you. Bye.